Dear students, in this video I explain series solution of Legendre differential equation. So the Legendre differential equation is in standard form, that is 1 minus x square into y double dash minus 2x into y dash plus n into n plus 1 into y is equal to 0. So here we need to find the series solution of this Legendre differential equation. That was here we use power series method. So here power series method, here we already in last video I explained power series method and also Frebonius method. For finding series solution of Bessel differential equation we use Frebonius method, but here we use power series method. So here 1 minus x square into y double dash. So the coefficient of y double dash is the p naught of x value, coefficient of y dash is the p1 of x, and coefficient of y value is the p2 of x. So here if p naught of x is equal to 0 at x is equal to 0, then we use Frebonius method. If p naught of x is not equal to 0 when or at x is equal to 0, then we use power series method. First we check. So here p naught of x value 1 minus x square. P naught of x value 1 minus p naught of x value 1 minus x square. So now in this equation take x is equal to 0. X is equal to 0, then which is equal to 1 minus 0. So 1 minus 0 which is equal to 1, which is not equal to 0, then here we use power series method. According to power series method, we assume the solution of the differential equation is y is equal to summation r is equal to 0 to infinity ar into x to the power of r. So here in this equation y double dash and also y dash is there. So using this equation, first we have to find y dash and also y double dash. So derivative of y is y dash, summation r is equal to 0 to infinity, ar is constant, derivative of x to the power of r is n into x to the power of r minus 1. Again differentiate with respect to x, derivative of y dash is y double dash, which is equal to r is equal to 0 to infinity, r into r minus 1, r is constant, ar is also constant, derivative of x to the power of r minus 1 is r minus 1 into x power of r minus 2. These two values kept in this equation. So then summation r is equal to 1 minus x square into, so I directly multiplied with 1 minus x square also. So summation r is equal to 0 to infinity, ar into r minus 1 into here x square is there, x square into x to the power of r minus 2 into 1. Okay, x to the power of r minus 2. So then minus summation r is equal to 0 to infinity, ar into r minus 1 into x to the power of r minus 2 into x square become 2 to become cancel, minus x to the power of r minus summation r is equal to 2 into infinity, 2 into here y dash ar into r, x to the power of r minus 1 into x, it become x to the power of r plus n into n plus 1 into y value, summation r is equal to 0 to infinity, ar into x to the power of r. Call it as equation number 2. Now using this equation we have to find a0, a1, a2, a3 value. That wise first equating the coefficient of x to the power of minus 2. Take x to the power of minus 2 means here in this equation take r is equal to 0 and then equating the coefficient of x to the power of minus 2. Then simplify, here we get this condition a0 is not equal to 0. And then equating the coefficient of x to the power of minus 1. It means in equation 2 we have to take r is equal to 1. R is equal to 1. So take the coefficient of equating the coefficient of x to the power of minus 1. Simplify this, then we get a1 is no, simplify, we get this condition a1 is not equal to 0. Then here in this equation here are all the term equating the power of x to the power of r. That was in first term take r is equal to r plus 2, take r is equal to r plus 2. So simplify. Here we get r is equal to 0 to infinity ar plus 2 into r plus 2 into r plus 2 minus 1 into x to the power of r plus 2 minus 2 become x to the power of r minus summation r is equal to 0 to infinity ar into r minus 1 into x to the power of r minus to summation r is equal to 0 to infinity 2ar into r x to the power of r x to the power of r x to the power of r plus n into n plus 1 into summation r is equal to 0 to infinity ar into x to the power of r. Now in this equation now we are equating to x to the power of r. X to the power of r, then here ar plus 2 into r plus 2 minus 1 become r plus 1 minus ar into r plus 1 r into r minus 1 minus 2ar into r plus n into n plus 1 into ar is equal to 0. Then here this three term shift to LRHS, it become, and then simultaneously take ar as the common factor, then r into r minus 1 plus 2r minus n into n plus 1. Then at last simplify this equation. Here we get ar plus 2 minus n into n plus 1 minus r square minus r divided by r plus 2 into r plus 1 into ar. If you are interested in this two term, we take r as the minus r as the common factor, it become minus r into r plus 1. Now in this equation now we know a naught is not equal to 0 and also a1 is also not is equal to 0. Now take r is equal to 0, 1, 2, 3, 4 etc. in this equation. Now take r is equal to 0. We get 0 plus 2 become a2 minus n into n plus 1 by 2 into a naught. Now take r is equal to 1 in this equation. Simplify. Here we get a3 value minus n into minus n minus 1 into n plus 2 by 6 into a1. Now take r is equal to 2, it become a4 which is equal to minus n minus 2 into n plus 3 by 12 into minus a naught value minus a, we get a1 a2 value, but again I substitute a2 value also, that is minus n into n plus 1 by 2 into a naught. Now take r is equal to 5, then a5 is equal to minus n minus 3 into n plus 4 divided by 20 into a1, but I substitute a3 I substitute a3 value also into minus n minus 1 into n plus 2 by 6 into a1. Now this goes on continue up to nth term. Now we know that the series solution of the given differential equation in the form of y is equal to a naught x plus a1x plus a2x square plus a3x cube. So this can be separated as like this: a naught plus a2x square plus a4x to the power of 4 dash 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 plus a1x plus a3x cube plus a3a5x to the power of 5 dash dash dash. Now substitute a naught and also all the values. Substitute a naught, a1, a2, a3, a4 value. So here the simplify, here we get this equation. Okay, then this equation is in the form of y is equal to a naught. Then this whole term we can return as, then here the whole term can written as y and this whole term consider as a v. Then the given equation is in the form of y is equal to a naught into u of x plus a1 into v of x. This is the series solution of, because it is a function of x now, just we are represented by u of x, and also this one is also series solution with respect to x, then we call as another variable, that is v of x. Therefore y is equal to a naught into u of x plus a1 into v of x. This is the solution of Legendre differential equation. Next we come to Legendre polynomial, or we use Rodriguez formula. So that derivation is not important in exam point of view, that was just explain the P1x Rodriguez formula. So Rodriguez formula means Pn of x is equal to 1 by 2 to the power of n into n factorial into d to the power of n by dx to the power of n into x square minus 1 whole to the power of n. Now using this equation, first we have to find P0 of x, P1 of x, P2 of x. So that is using Rodriguez formula, obtain the expression for P0 of x, P1 of x, P2 of x, P3 of x, and also P4 of x, and hence express x square, x cube, x to the power of 4 and also x to the power of 5 in the term of Legendre polynomial. So the Legendre polynomial Pn of x in the form of 1 by 2 to the power of n into n factorial into d to the power of n by d x to the power of n into x square minus 1 whole to the power of n. Now take n is equal to 0, 1, 2, 3 in this equation. Take n is equal to 0. We get P0 of x 1 by 2 to the power of 0 into 0 factorial into d to the power of 0 by dx to the power of 0 into x square minus 1 whole to the power of 0. So sum to the power of 0 value 1, then we get P0 of x value 1. Now take x is equal to 1. In this equation it become P1 of x, which is equal to 1 by 2 to the power of 1 into 1 factorial into d by dx of x square minus 1. That is 1 by 2 into derivative of x square value 2x. 2 become cancel, we get x. Now take x is equal to 2 in this equation. That is Pn of P2 of x. P2 of x is equal to 1 by 2 square into 2 factorial d square by dx square into x square minus 1 whole square. Now this term differentiate 2 times, then here we get 1 by 2 into 3x square minus 1. Now x is equal to 3. X is equal to 3, here we get P3 of x is equal to 1 by 2 cube into 3 cube into d cube by dx cube into x square minus 1 whole to the power of 4. We differentiate 3 times this equation, here we get 24 by 48 into 5x cube minus 3x. So like that we have to find this value. So then using this equation, next we have to find x square, x cube, x to the power of 4. So here we simplify, just find x square value. Here P2 of x can be written as 1 by 2 into 3x square minus 1 na. So it can be written as 2 into P2 of x is equal to 3x square minus 1. Then this minus 1 is shift to left side, it become 3x square is equal to 1 plus 2 into P2 of x. Okay, then but we need to find x square now, so that is x square is equal to 1 by 3 into 1 means P0 of x plus 2 by 3 into P2 of x. Okay, next, because this is very useful for solving the problem if you know this result. Next, P3 of x can be written as 1 by 2 into 5x cube minus 3x. Then by cross multiplication it can be written as 2 into P3 of x is equal to 5x cube minus 3x. Then 5x cube is equal to 2 into P3 of x plus shift to LHS it become plus 3x. Then x cube is equal to 2 by 5 into P3 of x plus 3 by 5 into P1 of x. Okay, next x means your P1 of x. Next we come to P4 of x. P4 of x can be written as 1 by 8 into 35x to the power of 4 minus 30x square plus 3. Then by cross multiplication 8 into P4 of x is equal to 35x to the power of 4 minus 30x square plus 3. Then x to the power, we have to find x to the power of 4 now. So 35x to the power of 4 is equal to 8 into P to the power of x plus 10 into 30 can be written as 10 into 3, 3x square minus 3. At last simplify, we get x to the power of 4 is equal to 8 by 35 into P4 of x plus 4 by 7 into P2 of x plus 1 by 5 into P0 of x. Same type, you are using P5 of x is equal to, we have to find x to the power of 5. X to the power of 5 can be written as 8 by 63 into P5 of x plus 4 by 9 into P3 of x plus 3 by 7 into P1 of x. Okay, now this is the values. Now using these values, next we have to solve the problems. So first problem, using express x cube plus 2x square minus 4x plus 5 in term of Legendre polynomial, or sometime as using Rodriguez formula expressed as a Legendre polynomial. It is very simple. First write down the given function, that is f of x is equal to x cube plus 2x square minus 4x plus 5. We already we know x means 1 means P0 of x, x means P1 of x, x square means 1 by 3 into P0 of x plus 2 by 3 into P2 of x. x cube means 2 by 5 into p3 of x plus 3 by 5 into p1 of x. X to the power of 4 means 8 by 34 into p4 of x plus 4 by 7 into p2 of x plus 1 by 5 into p naught of x. Now all the value substitute in this equation. Okay, that is here, that is f of y is equal to x cube means here 2 by 5 into p3 of x plus 3 by 5 into p1 of x plus 2 into x square. X square means 1 by 3 into p naught of x plus 2 by 3 into p2 of x minus 4x minus 4 into x can written as p1 of x plus 5 into this means whose understood is whose coefficient is 1. 1 can written as p naught of x. So simplify this equation, we get 2 by 5 into p3 of x plus 4 by 3 into p2 of x minus 17 by 5 into p1 of x plus 17 by 3 into p naught of x. Same type, just rewrite the equation, you just substitute x, y and also x square, x cube depending on the equation. We know that it is expressed in term of Legendre polynomial. We get the solution. Thank you.